Coal processing, the second part. You will remember in the first part we had a look at the different mining techniques, and then we mentioned something about the cleaning of the coal before it can be converted into other products. And then we had a look at combustion, where coal is used to heat boilers, you will remember. Now in this section we are looking at destructive distillation. Now in destructive distillation, the reaction is also a heating of the, or an initial heating of the coal. The difference from combustion, in combustion air is included. Air blast is actually added during the process. Destructive distillation, the heating is done, but it's done in absence of air, so that you don't have any burning of the coal. Again, it depends on the types of coal that is used. Now, what happened in this process of pyrolysis? At first, as the temperatures start to increase, the aliphatic carbon-carbon bonds break first at about 200 degrees. Carbon-carbon bonds not as strong as carbon-hydrogen bonds. Now, carbon-hydrogen linkage breaks only when you come to 600. So you see the coal is now slowly, the heat is increased, and as it is increased, there's a breaking down of the coal. Elimination of heterocyclic complexes and progressive aromatization are reactions taking place. So you have different products coming free, and as they come free and the temperature increase further, the weights of the products decrease because they become smaller and smaller particles as the temperature increase, and these smaller ones then will have less much weight. And last of all, we have here the decomposition is maximum, where most of the bonds will be broken, or most of the smaller products then will be formed between 600 800, and you are left with your coke, which is a solid product of the destructive distillation, and your tar, and then the vapors, the gases, which is mainly ammonia with some other impurities. Now, in coking of coal, what is the meaning of coke? Coherent cellular residue. It's the result of destruction. That it's now during this bond breaking that we just discussed that you are going to have the coke produced. Rich in carbon, contains just a small amount of gas, volatile matter. Now, a good coking coal must have between 20 and 82% of volatile matter. You need not to remember the figures exactly, but it is good to take note. It should not be too much, because if the gases, if they are too much, as they say here, then it becomes difficult to handle all the gases that is released during the coking process. And if it is too little, if it's a too low percentage, the coke will not have enough porosity, and you need the porosity for complete reaction, for better reaction in the metallurgical processes. It must also contain sufficient ash, so it should not have too much, but it should have sufficient. The ash helps to decrease the melting point, so that the coal can be changed into this plastic mass that we refer to as the coke. The expansion of coal during the distillation process must be low, and it must not have too much sulfur and phosphorus, because if we then continue with this coke further and we use it in the extraction of iron from iron ore, the pig iron that is formed will be contaminated by the sulfur and the phosphorus. It's better if you don't have that. Now, what are the properties of good coke? Coke that is excellent for use in the blast furnace for iron production. The coke must be strong enough, must not break easily, because if it breaks, you can imagine it's going to cause blockage of the air passage. The abrasive strength must also be sufficient. It must not disintegrate easily. The impact strength of the coke must be sufficient to prevent breaking during handling. And it must be open enough structure. The pores, it must be porous enough, because the more porous it is, the greater the area contact. And that is exactly what you want, because the coke is now going to facilitate the reduction process. The ideal size, between 78 and 100 millimeters for the coke. And it is used in the blast furnace. The basic reaction in the blast furnace, the coke is going to give heat, but it's also going to reduce. So it's not just providing the heat, it's basically two functions in the blast furnace, the heat as well as the reduction of the iron oxide to iron. Byproduct coking is referring to all those extra products, namely the tar that is produced, and then the gases, all the waste gas that also come from this breaking down during the heating of the coal. You can just have a look, please. It's not necessary for us to go and memorize this. As long as you can understand what they try to say to us. There the coal is coming, and you have the crushing and screening and going to the oven bin, and the coke is formed inside the oven, immediately quenched with water. So it's basically covered with water, because you don't want the coke to start to ignite immediately. It should not burn. The coke must be used further on in the blast furnace. The FOW they refer to here is the pipeline along which the waste gases and the tar and those things move, so that further purification can take place here. I think it will be best if you look at the theory that is discussed in the next slides, and then come back to this flowchart. It will help you to understand better what they have for us here. Byproduct coking just explain to us the heating of the coke, of the coal to produce the coke. Air is excluded, because there should not be any burning of the coal. The heat is supplied by flue gases on the sides of the oven. They give you an idea of what the size is and the fact that they work in battery form. The coke ovens operate intermittently. Each oven is stopped and started at different times to ensure that the entire block continually produces gas of good average composition. That is now this gas that we had on that flow sheet, that is transferred further and purified and separated. The crushing and screening we talk about. In the oven, the heating, so the production of the coke itself. The reaction taking place inside there, as long as air is excluded, destructive distillation. And once the whole process is done and the breaking down is covered, and you reach that highest point where all the bonds are broken, then the oven doors are opened and the red hot mass is pushed out of the oven by an electrically driven arm, and it is inserted in water. Water is covering it. It is very hot as it comes from the oven, and if you just have it exposed to the air, it can ignite, and that's exactly what you want to prevent when you do destructive distillation. You want that coke to be used further. They just refer to what happened during the crushing and screening and the gas regeneration. The gas regeneration we are going to have a look at now in the next slides. But that is basically where the gases are separated, and what is actually waste gas is returned as fuel, so that they can provide further heat during the process of the destructive distillation. So it's not really product, it's more a source of heat than anything else. You see, the byproduct steps here. Refer now to what happened basically to the gas that come free. It's during the destructive, the gas that is formed during the destructive distillation, and the liquid and solid, all of it is entering the collecting main. Now solid from there is it's basically if there's any solid except the coke itself, because the coke is going from the oven directly to the quenching process, from where it's then going to the blast furnace or whatever other metallurgical process want to make use of it. The gases that is formed during the breaking of the coal leaves the oven, and it is sprayed with ammonia, which condenses it, and in the primary condenser it is cooled and compressed, and liquid forms. You have your tar extractor that is collecting the tar. It is the liquid product from the coal during the destructive distillation. And in the tar extractor, the purification leads to ammonium sulfate, light oils, and gas. We have the tar separator there, where you have further separation taking place, and the lime store, where either you have waste or ammonia that can be further purified.